Okay, since we're still getting a few more attendees joining as of now, we'll wait for another 5 more minutes before we begin the webinar. Till then, Shrika, can you refer to the Q&A sections? I believe there's a few questions that you can answer.
Okay.
Okay, good afternoon, everyone. Welcome to the Game Development Workshop organized by the GIIS Tech Club 2021 under the aegis of the IT department of the school. My name is Ayushmaan. I'm the Vice President of the GIIS Tech Club, and I'm joined by Srikar, who is the President of the Tech Club. And we're going to be teaching you guys how to develop your own games to the Unity 3D engine. So I hope everyone has taken note of the current slide and has been able to either get hold of a device that has Unity already or has been able to download Unity. If you haven't been able to download Unity because of any technical issues, don't fret, because a part of this webinar is to give you an introduction to the game development industry and the process that goes behind developing games, so you can still follow along even if you don't have a device with Unity on it. So who are we? GIS Tech Club is a group of passionate teams who love technology and would like to share their passion with everyone else. So we have almost 17 team members, and we are organizing these open workshops as a chance to spread our love for technology with you guys as well. So you can take note of the same. So this is the schedule for our upcoming workshops. Today is the first workshop in this series, which is on game development. We have a workshop on June 1st on 3D modeling on the Blender software. June 2nd would be a Python automation workshop. June 3rd is a web development workshop with Python. And June 4th is an app development workshop with MIT App Inventor. So do take note of these same and attend those if you want to as well. All right, just to give you a brief introduction to what we're going to be discussing in this webinar, we're going to discuss some things about the game development industry as a whole and what kind of careers you can go into under the aegis of game development. We're going to talk about the process that goes behind developing many of the games that we play these days and what are the tools that are used to create these games. We'll give you an introduction to the Unity software and the game engine and also make a short game in Unity. We won't be going all the way in making different levels and then exporting the game, but we're going to give you a basic overview of Unity as a software and how you can go about creating your own game as well. And also for a surprise, we're going to introduce shooting mechanics in Unity to show you how you can implement shooting in different ways in your own game if you want to. And lastly, we'll discuss a few different types of games to help you move along in your game development journey. All right, before we start with the content part of this webinar, if you guys have any questions related to the webinar as a whole, you can direct them to the Q&A section and either Srikar or I will be able to attend to those questions when we get time. Okay, to talk about the game development industry, it is one of the largest entertainment industries on the planet. And as you can see, the total revenue for this industry exceeded 165 billion US dollars in 2020. And unlike previous years, game development industry does not just comprise of huge studios building AAA games. Due to the increase in popularity of game engines such as Unreal and Unity, we now have indie stores and indie game developers that are developing games of such high quality that we can still see them on the Google Play Store and App Store that are trending. All right, to talk about different kinds of careers in game development, what I like personally about game development is that it is a vast field and it comprises of almost every single entertainment field under computer science that you can think of. So obviously you have the scripters and the programmers and the software developers that actually end up coding, but then there's other parts to game development as well. You can think about going into 3D modeling and asset designs to create the actual assets that are displayed in the game. You can go into animation, so you can animate the different assets in the game. You can go into sound synthesis, video editing, and post processing, and even just storyline creation as a whole. There's a lot that you can do under game development, and there's no such title as a game developer unless you're on an individual scale. If you're working on a team, you'll always divide it into different roles yourself, and you yourself will be able to see which role you're most suitable for once you start developing your own games on a small scale. So here are just a few introductions to some of the most popular game development careers. So one is obviously the game designers that actually end up putting everything together. So the assets, the scripting, the animations, and the graphics, the game designers put everything together. Software developers are those that handle the scripting part of it. When we talk about scripting, what we mean is if you have an object in your game, it has to interact with the user's input somehow. So if you're pressing W in a game, we need to tell the object or the character to move forward. We do that using scripting, which is basically programming code. And that's what the job of software developers is. Thirdly, we have the animators who work on the animation part of it. So basically just the movement of the arms or the face in cutscenes. That's what animations are supposed to do. And they often use specialized software rather than doing it in the game engine itself. The fourth would be a weird one because we don't really think about it, but video game testing is an actual career as well. Although it is done more on a freelance basis, you can actually become a video game tester where you basically carry out different tasks and figure out bugs in the game that you report to the game development studio, and then you get paid in exchange for it. Moving on, we're going to talk about the game development cycle. Okay, so there's 7 steps to developing a game. The first step is obviously planning the game because you can't go ahead and develop anything without knowing what you're going to develop in the first place. The second step would be the pre-production, which is sort of like a continuation of the planning stage, but more in depth. So you start ironing out the rough edges and just finalizing all the details before you actually get into the Unity software and make your game. Uh, Third is production, obviously, and production comprises of all the jobs of the various careers that we discussed in the previous slide. So you're gonna have 3D modelers designing assets, software developers coding the scripts behind it, animators would be doing animation, audio synthesizer would be working on the background music and sound effects. So all that happens in the production stage of it, which is one of the largest stages in this game development cycle. The fourth is testing. So once you're done with the game and you want to release it on the App Store or the Play Store or Steam or Epic Games, you can't really release that without testing it out yourself, because obviously during the production process, it gets stretched out so much that you don't really notice or tend to notice bugs or errors in your game until it's too late. So that's what the whole testing part of it is about. So the big AAA and AA games spend months in testing and ironing out their bugs and errors before you actually get to see the game on the market. So testing is also a huge part of the game development cycle, even though most people tend to disregard it. Pre-launch, launch, and post-launch are somewhat related to each other. Pre-launch mostly works in terms of investment and advertising. Advertisement. Launch is also mostly advertisement, and then post-launch comes with including DLCs and updates for the game. Okay, so planning a video game. There's a lot of questions that you need to answer when you plan a video game, because, as we all probably know, there are various types of video games, and if you're not clear with what you want to do, you're gonna end up getting stuck and you're gonna get burnout, which is basically that you have a lot of ideas and you don't know how to implement them, or you don't have any ideas and don't know what to do next. So a few examples of the questions are: what type of video game is being produced? So we're going to talk about this towards the end of the webinar a bit more into detail, but there's different types of games as well. If you've played Fortnite or PUBG, those tend to come under the battle royale genre of the games. If you play Counter-Strike, that's a first-person shooter. League of Legends is an RPG strategy game. So there's different types of games, and all games have different audiences and different features. So if you're not clear about what direction your game is headed in, you won't be able to attract the audience, nor would you be able to efficiently produce and include all the features in the game that you wish to include. The second most important question is, will it be 2D or 3D? Now, generally, when we talk about massive AAA games, we tend to regard them as 3D, but 2D games are also a huge field or industry. So you need to make sure that you are clear whether you want to head in 2D or 3D, because again, there's different development processes that go into the same. And you can go through the other questions, such as what are some of the key features. This again depends on the type of the video game you're producing. Who are the characters? When and where does it take place? Who is the target audience? And what platform is the game going to be built on? These are all important questions that you need to be sure of before you actually start planning your video game, which is the next step. When we talk about platforms, we're not really referring to Unity or Unreal, because they count as game engines. They're the softwares on which the game is developed. Platforms are what the game is going to be running on. So one of the platforms can be Windows, Mac OS, or Linux. So those are the three major platforms, and each of them have different optimization settings. So if you're specifically looking for making a game on Windows or Linux, there's different settings you can change in your game engine like Unity that would help you optimize your game further. But if you're going for an all-around approach, there's other rules and regulations that you have to abide by. Okay, so when we talk about the pre-planning stage of a game, I guess this meme that Srikar has put in describes the process as a whole, because there's a lot of communication and a lot of steps that go into developing a game, and there's bound to be miscommunication in some sorts. So you can see that the first slide in this comic shows that the customer explained that they wanted a game like this, but then the customer actually needed a game like this. And then we see how different parts of the game development studio, or like different people in the game development studio interpreted it, and how it actually ended up being made. So that's the whole point of game development pre-planning. You need to make sure that you're thorough with all the questions that you've answered in this stage, and that you know that you're clear with where you want to head in before you start making the actual game. Because once you start making the actual game, designing objects and stuff, it can end up stretching out to weeks or even months of work. And some games often end up being in production stages for even years. So if you're not clear about these questions, you're going to end up messing up and you may have to end up starting over again. Okay, planning a video game. This doesn't really apply to you since you, as of now, you'll be developing more on individual scale. So I'll just briefly skim through this. But the budget of a game development studio and the methods with which they can gain funding are two major factors through which they can determine what kind of game they're going to be developing, how many features, and how graphically intensive the game can end up being. So if you have a low budget and low methods of monetization, or like basically no methods of monetization, we obviously know that the game won't end up being as extensive as it possibly can be. Okay, pre-production stage. Pre-production is basically every single different career under the game development cycle getting together with their group and planning what they want to do. So the point of this stage is that the artists and the graphic designers are aware of what they want to develop in terms of the assets. The software developers are sure about what features they want to implement into the game. The animators are sure what kind of animations and cutscenes they want to put in. So this is basically us taking notes before writing the exam, if you want to think about it in that way. Okay, the production part is pretty simple, and that's what we're going to cover today. So production part is basically when you actually get into the softwares for your different fields, and if you once you get into softwares of your different fields, you want to start working on the stuff that you have to do. So if you're doing asset design, you want to start modeling, sculpting, and texturing different assets for the game. Like if you want to make a shooting game, you have to design the guns, you have to design the map, and that all comes under the role of the asset designer. If you're a software developer, you have to implement shooting in the game, which we're also going to show you towards the end of the webinar. So you have to start working on that through scripting. But the thing is, all these production processes need to be combined, and every single part of the production process needs to be in well communication with the other part, because otherwise we won't end up having a well-oiled game, because everyone's going to be doing their things in slightly different ways. And on small scale projects, it ends up working out fine. But if you have hundreds of thousands of people working on a single game and each person is doing their own thing in a slightly different way, the final product is not as good as it can end up being. Okay, next, testing. So testing is what I talked about when we were discussing the careers as well. So you give the game to in early access or in a beta release, and that's when people actually go through your game. They wander around the map, they test the different implementations, the features, and that's when they decide whether your game is buggy or not. When we refer to bugs or errors, we mean things working in ways that they're not supposed to work or things not working at all. So maybe if we think about this, if you implement jumping in your game, but don't put any restraints on the jump, people can just spam spacebar and jump forever and fly in space. So although you've implemented jumping, it's still a bug and people will figure this out during the testing phase. And that's when they're gonna end up telling you how you're gonna fix it. So that's the testing phase, and it is very important before launching it. Okay, I'm gonna go through the pre-launch, launch, and post-launch in like very quickly because they're not really important. So pre-launch is final bug testing and the marketing team. So this is where we first start. This is where we first start, actually releasing the game to the public. This can be the first trailers or the first advertisement posters being released, and then if you're working in a huge game studio, you can actually go on to events such as E3 and market your game there as well. So that's what the whole pre-launch stage is about, which is basically marketing and final bug testing. Okay, the launch of the game. So the launch of the game is essentially pre-launch but on steroids. The whole point is this is when your game is actually released to the public, and that's when you start coming up with sponsorship ideas as well. So if all of us here are familiar with gaming YouTubers and gaming streamers on Twitch, we all know that they get sponsored by various games or game studios to play their game and display their game to the world. And that's what launch and post launch end up coming under. So launch is basically an added step in the advertisement process, but it comes up during the game's launch phase. So on the day the game is launched and in the few weeks afterwards, that's when we're in the launch phase of a game. That this is when the post-launch period comes up. So post-launch is a few months after the game has been developed. So the point is there's always going to be a few bugs and errors that weren't fixed during the testing and the pre-launch phase, and they end up going out into the community. And that is the case for every single game. Like you cannot avoid any bugs. And because even if you don't have bugs or errors, there's obviously things that can be done better. And that's what happens when you get feedback from the community. So once you start getting that, you start releasing bug patches and more updates to improve the gameplay. Because during the launch and testing phase, you can't really do that. But once you're in post-launch and the bulk of the game is out, you can keep rolling out updates to improve the quality of the game. And after updates are over, you can also think of DLCs, which are packages that the players pay for and they get extra material for the game itself. That's what DLC stand for, and those are a viable option post launch as well. Now you don't really have to worry about this as of now since you're more of an individual developer, but do note that this is how a game development studio goes about developing a game. Okay, this is a conclusion slide, so I'll just go through, like recap everything that we've done till now before we start developing our own game. So we go from planning to pre-production. Planning is basically you plan the type of the game and whether you're going to go into 2D or 3D, what is the budget, who is the audience, and what platform will it be on. So the very basic questions that you should start asking before you even think about developing the game. Pre-production is basically you planning what you're going to do for the different areas of your game. So asset design, coding, and animation, they're all decided in pre-production. So during production, you don't really have to use your brain a lot. You have all the notes and plans from the pre-production phase, and production is more of the bulk work. Launch is you go from production to testing, which is basically bug and identifying and fixing errors. And it's not just that. If you end up testing your game and you realize that it's way too hard or way too easy, you can change the difficulty by changing different aspects. So if you're making a game like Subway Surfer and it turns out there's not enough obstacles in the way and the game feels too easy, you can increase the density of the obstacles that are coming in the way, and that way the game ends up being more balanced. So that is another part of the testing feature. Pre-launch, launch, and post-production have been discussed in depth, so let's not really worry about that. But you can go through this and keep note of this graph, because even though you're on individual scale, the planning, pre-production, production, testing, and launch phases of the game still apply to you, even though they're on a smaller scale. So you don't really have to worry about advertising your game as of now or releasing it on like a huge scale. But it's just that you have to be wary of these steps, because if you end up directly jumping into production or launching without testing the game, then it's not going to be as good as it could have been. Okay, so there's different game development methods used in the industry, which are in terms of the SDLC or software development life cycles. The most common game development method is the waterfall method or the trickle down method. In this case, the top bunch of main developers are given all the information that they can acquire about the game through the pre-production and production phase. And after that, we end up distributing that information to the rest of the game development, the game development studio. So the point is the main developers know what is to be done in terms of asset design, scripting, and animation, and they pass on that information to the various departments. So there's a bit of a hierarchy system in place, and that just makes it more efficient. Okay, so I've been rambling on about how games are developed as a whole, but what exactly can you use to develop games? So there's a lot of game engines out there, and some of them are more common than the others. So we're going to be discussing the two most common game development engines that are now, which are Unreal and Unity. Okay, Unreal Engine. If any of you have played Fortnite, you'd know Unreal Engine, but just to recap for those that haven't played the game yet or don't know Unreal Engine, Unreal Engine is one of the most powerful game development engines, and it is used by almost 50%. I'm not really sure about the statistics, but it's used by a majority of the industry when it comes to developing large scale games because of its superior graphics engine and the fact that it has blueprint coding in it as well. So you don't really have to type out code. You can use a block format of the code to develop games as well. So some examples of the games developed using Unreal Engine are Fortnite, Survival Evolved, Tekken 7, and Kingdom Hearts 3. So you can read about Unreal Engine online as well. But we won't be using Unreal Engine for the purposes of this workshop because Unreal Engine is not beginner friendly in a sense. So it's better to start off with Unity because it's more user friendly. And after that, once you're comfortable with Unity, maybe you can start transitioning to Unreal Engine because each engine has their own advantage in a sense. But at the individual stage, it doesn't really matter for you to take advantage of the superior engine of Unreal Engine. You can just stick with Unity and you'll be fine. Okay, Unity. Unity is a cross-platform game engine which was released by Unity Technologies in 2005 and has gotten various updates since, and it is one of my favorite game development engines as well. So Unity has the ability to produce both 2D and 3D games, and the UI and the production process in Unity is actually very simple. The coding in Unity is done in C Sharp or JavaScript, although most of the industry prefers C Sharp. And Unity now has support for over 20 different target platforms, including PC, Android, and iOS systems. So that's what makes it the ideal game development engine to start off of because it makes it easy to develop and then launch your own games for yourself so you can test it out as well. Okay, so this is the Unity setup guide. If you have not done this yet and you have your own device with you, not the school issued devices because they don't really allow you to download Unity without the admin password. So if you have your own device with you, you can go to the website mentioned here and follow the steps to download Unity. You can take a screenshot of this slide so I can move on. Okay, so once you're done downloading Unity, it's going to download Unity Hub and then download a version of Unity into it. So after that is done, you have to make a Unity account. So what you do with the Unity account is you just enter your email ID and your password and you sign in and they give you a personal license. Another good thing about this is that the personal version of Unity and Unreal Engine as a whole, they're free. So you don't really have to pay for them. And as a beginner game developer, you won't really need to take advantage of the professional tools that are needed for developing games either. That's what makes Unity my favorite game development engine as well, because it is free for individual developers to test out. Okay, so now we're going to go into the introduction to the Unity engine as a whole. I'm going to stop screen sharing and Srikar is going to start screen sharing and we're going to walk you through the Unity engine and its layout and how you can start developing your own game. If you have any questions as of now, you can direct them to the Q&A box and I will be answering them while Srikar introduces you to the Unity engine. Srikar, we can't hear you.
Am I audible now?
Oh yeah, you're audible and you can see your screen as well, so you can begin.
Okay. So this is how the Unity engine looks. This is just a sample scene. So that's why this place is full. So I'll create another folder and create a new scene. So if you want to create a new scene, you right click, you go into create, and then scene should be where my cursor is now. I'm naming this scene test, and I'm opening set scene. So Unity always starts you off with a main camera and then a directional light. You don't have to worry about these for now, just where the main camera is. So now, just to show you a sample of what we're going to be seeing today, um, I'll just run a sample of this game. So first, this is just a basic obstacle course, and the game stops when you hit the obstacle. And there's also a challenge for you guys for the people who have Unity installed on their engine. So we'll get to that later. Now I'll be showing you how to create the game I've shown you just now. So first, you go and then you create a 3D object. Just it can be a cube for now, and we'll name it ground. Then we're going to go over here to transform and then set the position to 0, 0, 0 because it's easier for us to do our calculations for movement that way. And since this is going to be the ground, we're going to make it scale about 10,000 in the Z direction and 15 in the X direction. And then this has a collider, which is very important for later. And I'm going to create our player. So our player is going to be at the 0, 1, and 0, so we can see the player. And now I'm going to introduce you to a texture. It's called material. And by making this, we can make the object that's over here distinguishable. So I'm going to name this player also. And if you press on the little ink dropper here, you can set a color from the screen. But since I don't want that, I'm going to click in the middle and I'm going to choose a color of red. So after this, either I can go over there and drag and drop it into player over there, or I can drag and drop it on the screen here. And then after going into player, the first thing we're going to do is check to see if gravity works. And it shouldn't work right now because we haven't added physics to this engine yet. So it should just stay in the ground. Okay, and then we're now going to go here and go into click on the add component and then type in rigid body. Since this is a 3D game, we're going to be using rigid body without the 3D. If this was a 2D game, we would be using rigid body 2D. So rigid body allows us to add physics to the game. So over here, we're going to assume this block has a mass of 1. We're going to remove angular drag. And we can leave collision direction as discrete here because our game isn't really a shooter type game, so it doesn't have to be that accurate. And since the user gravity is ticked over here, it should fall onto the ground and stay there. If use gravity wasn't there, it should just stay exactly where it was. And it's also important to see that the ground also has a boss collider, because if we check that off, the player should fall straight through. If gravity was enabled, it should fall straight through. Yep. Okay, so now I'm going to reset the block to position 1, and I'm going to put the boss collider back on. And now I'm going to show you how to go into Visual Studio Code and make a script to allow the player to move. So to create a script, we go on to the project window over here. We go to create and we click on C hash script. So you can call it CS or C sharp. Ayushmaan calls it C sharp. I call it C hash. I'm going to name this player M, which stands for player movement. And when you double click on it, Visual Studio Code should start. I'll let that share. Give me 1 second. Ayushmaan, can you see my screen now?
Yeah, we can see Visual Studio.
Okay. So in Visual Studio Code, when we open a C sharp file, Unity gives us two functions, void and start. And function is basically a piece of code that when we call it in the actual code in Unity, it runs. So void start and void update are two generic functions. So start is run once before the first frame. So when we click,
1 second, Srikar.
yeah,
Just to interrupt you, we're getting a lot of questions in the sense of will the recording be shared with you guys? So we are recording this webinar and the recording will be shared, but since we don't really have a registration form, we're going to try and upload it on the GIIS Tech Club website when it goes live. And if you guys follow us on our social media, you will be able to know when the website goes live and you will be able to access the recording there.
Okay, and I see a lot of questions about Visual Studio giving a couple of errors. So, Ayushmaan, can you answer those while I keep continuing?
Okay.
So we have two functions here. One is start, and it's only called once. So when we go into Unity and we press the play button, that's when the start function is called. Now the update function is a little different. It's called once per frame. So I'm sure all of you know what frames per second is. But it's basically Unity creates the game by running a picture once every second, and that's basically what a frame is. So for player movement, we'll start by declaring a variable. So in C hash, since it's a object-oriented programming language, you declare variables with public if you want to edit them in the Unity code. So I'll just create one for now, public float. Let's call it forward force, and let's set it to about 500. And the F is just to make sure that Unity takes it in as a float. So now, if I go into void.start, void, I think we can delete void start over here because we don't need it for movement. So I'm just going to delete that. And the using system or collections, using system or collections dot generic, those two can be removed also. We only need Unity engine for this. And don't worry about the format of the statement here. It's a little advanced. It basically just calls another file stored in Visual Studio's source code. So for void update, we also want to declare another variable called rigid body. So what we want to do is apply a force to the rigid body of the player. So we'll call it public rigid body. So rigid body is the type and float is the type, and then the word after that is the variable name. So let's call it RB.
Shrika, 1 second. So we're getting a lot, like we got a few questions. I got them on personal message as well regarding what actually the code is about. So if you can go to the script, I'll explain a few things. So you don't really need to know this right now, but the rigid body is a component of the game object. So if let's say you're talking about a phone. So a phone is an object. So a component of the phone would be its operating system. So rigid body is a component. So we to access that component, we have to declare it as a variable. So we can refer to it in the script. So RB is the actual rigid body of our player, but rigid body alone is what Unity defines as the physics of the game object in general. So that's what we're trying to do now. And these are all defined before we do any methods or any implementation and code of them. So that's what Shrika is going to do now in terms of void update.
Okay, so there's two ways to move this block forward. One's using the function called transform, and one's using the function called add force. So I'll show you transform first. So since we called a rigid body RB, we're going to do RB dot, and dot is basically a method call. So since this is an object-oriented programming language, we use dot to call the methods that belong to the RB class. So we're going to type in add force for now. And add force takes an argument, which is basically the thing it uses to make its calculations uh, in a vector format. So in forms of x, y, and z. So since we want to go forward, and forward is defined in the the z direction, we're going to put a 0 comma 0 comma and forward force, and it should apply 500 over there. And since this is since C hash requires a semicolon to be after each statement other than function calls, I'm going to add a semicolon here, and I'm going to save this and go back into Unity, and it should reload everything. And now to apply a script to the player, what we have to do is drag and drop the script onto the inspector tab. And over here, we can see that RB, it also has to have a reference. So since the rigid body we want is the player's rigid body, we drag and drop this rigid body into there. And we define the forward force as 500, which might be a little too slow to see the movement. So I'm going to change that to about 1000. And since we defined it as a public variable, we can change it here. If we defined it as a private variable, we wouldn't be able to change it here. So as you can see, when we declared it as private, the forward force tab has disappeared. So I'm going to change it back to public. And I'm going to save. Since Visual Studio Code doesn't autosave, you'll have to save to see your changes back in Unity. And when I press play, the block should be moving forward. So as you can see, the block moved forward. But as you could also see, the block was tumbling, and we don't want that. We want it to go in a straight line, like we want it to go like this. We don't want it to tumble forward. So to change that, we'll go back into our old scene, and we'll go to ground. And over here, we'll make a new physics material. So it's the same as a material, just that it changes the physics of the engine. So go down here, select that, and we'll name it slip, because what's happening is the block is having a frictional force with the ground. So we'll change dynamic friction to 0 and static friction to 0. And now we should, when we run it, the block shouldn't slide off. Okay, and after this, we'll go back into player movement. And since we want our block to move from side to side also, when we press the A or the D button respectively, we'll use an if construct to implement this feature. So the if else syntax in C hash is if and then parentheses and then the logical statement. So here the logical statement would be input dot get key, and the difference between get key and get key down is that when we hold down the button in for get key, uh, runs the it runs the code, but for get key down, it runs the code every frame. So get key is better in our case, and then get key parentheses, and then let's say D to move right. And there's also another important thing I want to note over here. It's best if we use statements, and the best way to include comments in C hash is to use two backslashes, and we'll call this the forward force.
Shrika, can you zoom in a little bit?
Yeah, give me 1 minute.
It's on the bottom left.
Yeah, is it better now?
Yeah, it's better now.
Okay. If input dot get key D, we'll do RB dot add force. Um, since we wanted to move in the H direction now, we'll declare another variable called public float. We'll make it another float, sideward force, and we'll make this 150. Um, so we'll just call that variable here, and then 0 and 0. And since we're changing, we want to change the velocity, we'll use another argument called force mode. Um, Basically, this for acceleration, it disregards mass when you use force mode. So since we want to change the velocity, we'll set it on velocity change, and we'll add in semicolon. And for A, we're going to take the exact same thing, and we're going to copy paste and just change this to A. And since we want it to move in the opposite direction, we'll make this a negative force, so it's applied in the opposite direction. And another problem that may arise is because frame rates are different on each laptop or device, we can stabilize it by using this thing called time.delta time. You don't really have to understand this. It just fixes the frame rate. So after we do this, we should be able to use the A and D keys to move left to right. As you can see, the block moved to the right there. So I'll press the A key now to make it go to the left. And as you can see, our block is moving forward, but the camera isn't following it, and we can't really see what's happening there. So I'll write another script to make the camera follow the player. So I'll call it follow P. And once we open it in Visual Studio, we can remove the start function again, and I'll just go back into the presentation. So we need the camera to reference the position of the player. So we'll declare a variable with the transform type called player, and we'll declare another variable uh, which is a vector 3, so a three-dimensional vector called offset, since we can't have the camera right on top of the player. So in void update, what we want to do is take the position of the camera, and we can access that using transform dot position, and we want to make it equal to the position of the player and add that to the offset. So since I've coded this before, I know that the best offset would be -1 in the would be 1 in the y direction and 5 in the z direction. So I'll just put that in when I go into Unity. And again, to apply this script to the camera, we have to drag and drop it there. And since it's asking for the player argument, we drag and drop player over here. And we set the offset to 1 and 5 in the y and z direction, and we leave the edge alone. So when we run this, the camera should follow the player.
Shrika, the offset is supposed to be in -5 because you're going behind, not
Yeah,
forward.
yeah, my mistake, sir. It should work now. Yeah, so you can see it bounces because it's falling at an uneven angle. So to fix that, we can go and go to rigid body constraints and then freeze rotation on the X, Y, and Z. So it should go straight now. And as you can see, it's fine now. The next thing we'll be doing is adding a score to the scene. So I already have the score script ready because it's better to explain without writing it again. So I'll copy paste that and then I'll show you how it works. So we use something called canvas to display text on the screen. So this is just the basic stuff. You don't have to worry about this. But then after you go here, you can go in and then right click and then go into UI and select text. I've already done it here and named it to score. So I already have a score script ready. And over here, it takes two arguments, player and then score.text. Score.text is already here. And since it was just going into MS Paint and just creating a score, that was easy enough to do. So I'll just drag and drop player over here. And it should be, the score should be reflected on the top. So it's just 0. And I'll show you the score script so you can better understand what's going on there. So score uses using Unity Engine.ui. This has to be called because it isn't given in the default location. And then we declare public transform player, and then we declare a text variable called score text. And then if when we update, so this runs every frame, score text.text, the text attribute of score text, it's linked to the z position of the player, and it starts with 0. That's basically what this does. So as you can see, when we run it, it starts off at 0, and then as we move forward, it increases. So now I'm going to go into my other scene, which has everything set, and I'm going to show you collision over there. So over here, we can see that when we collide into a black object in front, um, the game restarts. So first we need to write a collision script for this. So I'm going to open my player collision script and explain how that works. So again, you can remove the two statements above Unity Engine again. We only need Unity Engine for this. And so over here it says public player movement. That's because my script for this scene was called player movement. So I'll just close the other ones. So this is how player movement worked. And since we just referenced that here and defined it as movement. So void on collision enter is another function given by Unity. We didn't define that. And it takes one argument, basically a collision type, and then collision info. And it uses the tag on the object to determine if the collision happened. So tags are over here. So over here we can set this to player, but since our collision doesn't require the player type to be set, we'll just leave that alone and we'll go to the obstacle. And as you can see, there's an obstacle tag been set over here. So when this player collides into obstacle, um, the on collision enter function is called, and then it checks if the object we collided with has a tag called obstacle. And if that happens, the block's movement is unable to false. It can't move anymore. And I'll explain the statement as we go further in. And then, as you can see over here, the player has a different highlight than the other pieces. It has a blue highlight. So a blue highlight occurs when we when you call a prefab. A prefab is basically the same as an object, just that it's standardized and that we can't change it anymore. We can change the ground attributes, but to change the player attributes is a little more difficult because it breaks the code. That's basically one of the only differences in a prefab and a regular object. And so I'll go into the game manager script now. And the game manager script, it has three variables. One is the complete level UI that was made in MS Paint and already put in. I'll show that to you later. And this is the restart delay. So when we collide with an object, there's a delay of 1 second and then it restarts. And we use a flag. Booleans are usually called flags because that's usually what they symbolize. So over here, we check if game has ended and we set that to false as default. And then we declare three functions. One's complete level. So if we complete the level, uh, we set complete level complete level UI dot set active to true. This loads the net scene. And then public void endgame. Void basically means that we don't return anything. So the way functions work, we usually return integers, strings, or something like that. But in Unity, most of the functions will be void. So if game is ended is equal to false, and when we call this function, that usually means a collision happened and the game is ended. So we set game is ended equal to true, and we use debug.log to print a message in the console called game over. And then we invoke is basically a function used to invoke another function in a certain amount of time. So we'll invoke the restart function, which is down here, with a delay of 1 second, which we set here. Then we go down to the public void restart function. This uses scene manager, which is another import statement. We have to call using Unity engine.scene management, or else this code would be underlined with red. So we'll use scene manager to load a scene, and we'll get the name of the active scene, and then we use that to go to the next one. So then we can go back to project, and I'll explain the other piece of code. So then we use public class integer. This is basically just the name, and we import game manager as a variable, and then we call game manager or complete level when we have a collision. And here's the script for the end of level. So we basically load the net scene, and I'll explain build in a couple of minutes. So for those of you who have Unity, I'll give you 5 minutes to try and code in the ability to jump by pressing the W key. If you can raise your hand for how many people have
Shrikar, we
Unity.
still have to cover a lot of stuff. So maybe the challenge can be for them to do it on their own. And just to let you guys know, a lot of the stuff that we're discussing right now, it might seem a bit too complicated for you guys, but it's just so that I can give you a complete overview of all the different niche things that you have to do when it comes to developing a game. The thing is, this project or this game is one of the most common beginner projects that people use to explain Unity as an engine. And we'll be sharing a few online resources and YouTube channels with you guys that you can watch and go into even more depth regarding the same project. And that would maybe help you guys in your future game development projects.
Should I just
Okay.
continue with Rekash now?
Yeah. Can you show them the solution to the jumping code first?
Okay. So how the jumping code works is we use the same input.getKey method, and then we this is just for debugging, so we can print statements in the middle of the code to see where we were going wrong. So I did that here. So debug.log, it shows the position, the y position of the rigid body, and our rigid body in this case is the player. And this is basically a check to see if to stop users from spamming the W key to jump higher and higher. So this checks if the Y position is less than 2, it allows you to jump. If the Y position is greater than 2, it just ignores the code doesn't run. And then if the Y value is less than or equal to 2, then we add a force, and we add a force upward in, and we multiply by that force by 500. So we apply a force of 500 upward. So I'll just show you how that works. So I'll go here. When I press W, it jumps, and even though I'm spamming W right now, it doesn't go any higher up. It only goes up when I touch the ground. And just to show you the game, so basically when I collide, it restarts. And if I can actually clear the level, it should go to the next one. This is the level complete screen, and this is the next scene. And since I don't have another scene after this, it just reloads the exact same scene. So I'll just show you how build works in a high level. So basically you go there and then you load all the scenes you want in the order that you want over here, and then you press build. And after you press build, it creates an executable for you to run. I'm running a Windows device, so it'll give me an exe. If you're running a Mac, it'll give you a DMG file, and build and run basically runs the file that runs the EHR that runs the DMG. And now, Ayushman, do you want to go into Rekas?
All right. Okay. So I get that a lot of coding till now would have been a bit confusing for you guys, especially that you're beginners. But don't fret. We'll try to figure out a way to share the PPT and the recording with you so you can refer to it again and again. And if you guys don't know this already, we Unity itself has a very extensive documentation which detail all the components of the scripting that we just did. So if you just Google Unity documentation and click on the first link, you'll see basically all the methods that we used in this tutorial. You'll see all the information about them there as well. So that's something you can refer to, and that's something I like about Unity as well. So, as promised, we're going to explain to you guys how shooting works in a game. So there's two methods of shooting in a game. So if you guys have played games like PUBG or Fortnite, you'll notice that when you're using guns, like regular guns, especially when you're using sniper rifles, sometimes when you shoot and it's at a larger distance, the bullet starts dropping down because of gravity, and you actually have to aim higher above than the actual target to make sure that you hit the target. That's what happens when you use a prefab based gun. So what it technically is doing, it's creating a small bullet object whenever you click the fire button, and it's going to add like a huge force to it. But the problem is that that force is not the only force on the bullet object. The gravity is still acting on it. So it starts dipping down. So that's a more realistic form of a bullet implementation. But if you're going to make close quarters shooting games such as Counter Strike, you want something a bit more instantaneous. That's where raycast comes in. So we'll explain the differences between the two, but what it generally means is that raycast, it shoots a ray outside of your the gun barrel, and as soon as the ray hits another object, it detects it and it reduces itself. While in terms of prefab creates a separate bullet object, and when the bullet object collides with the object, that's when the health is reduced. So Shrika will show you the differences between both the um, methods and how they look in Unity. And we also have the code available in the PPT. So when it is shared with you, you guys can actually use that code and implement it into your own games.
Okay, so in Unity, I'll load the scene for prefab first. So I don't have much here, it's just a demonstration. So when I press play, you can see how the red cylinder's bullet, you can see how it goes down and hits the obstacle at a lower point than at which it was fired. That's basically the problem with the prefab, and you can see it's pretty slow. And when the debug .log statement collision comes, it takes some time. But when I go into raycast, and this is just the source for the ray, so look at the bottom left corner, and that's how fast raycast works. So it was difficult to get the ray to be shown over here, but this debug.log statement shows how fast raycast usually is. And Ayushman, is there anything else that we have to cover?
Just show them the code for this.
Okay, so
Okay, so just a basic explanation of the code. So what we do is Raycast carries its own class. So this is a bit more high-end stuff. So you can just copy the code as it is if you want as well. But Raycast is a different physics feature. So you have to use a lot of components. So you can see in the if statement present, you see if physics.raycast, and then it has a lot of parameters that you may not understand right now. So again, this is where the documentation part of Unity comes in. If you go on to Google and search up Unity Raycast documentation, I'm going to do it side by side with you as well. Ashika, is it possible for you to display it as well? Yeah, okay. So when you go to Unity documentation and under physics, you go to Raycast, you see all the parameters that we are using with explanations regarding the same. So if you're ever confused and you can't find a YouTube tutorial or online tutorial regarding what you have to do, just try going through the Unity documentation and you'll be able to see like what actually happens behind the scenes in Unity, because this is developed by the Unity developers. Shrikar, that's it from mine. You can move on to the types of games.
and this is also the prefab code, and we'll share this in some way to you. It works the exact same way as the player code worked previously, and it's just different objects that are being used over here. That's it. And so there's various types of games. When you're developing a game, you have to select which kind of game you want to make, and it may be an FPS or an RPG or something like that. But it also has to fall under one of these subgenres. So some of them, I've written three over here. The first subgenre is action games. They can be platformers, shooters, and fighting games like Street Fighter 2, which is pretty old. Super Mario Bros. Is also pretty old. Shooters. So Fortnite counts as a third-person shooter, and Halo counts as a first-person shooter. And then action adventure games. Some of these count under action adventure games also, but adventure is also a specific subgenre of its own. Some examples of these are Legend of Zelda and text adventures, which is basically some of those mobile ads that you see in games sometimes for text-based options. And graphic adventures are some of your more standard types of games like Legend of Zelda and stuff like that. And role-playing games are also pretty famous. Some of them are Diablo, tactical RPGs, sandbox RPGs, and tactical RPGs. Some of them could come under Civilization 6. I don't know if many of you have played that, but that's also a pretty popular tactical RPG. Scrap Mechanic is another sandbox RPG. Witcher 3, all of those are also RPGs. And that's it for this presentation.
Okay, thank you, Srikar. So I'm in communication with the teachers regarding how we're going to share the we how we're going to share the recordings and the PDFs to you. So what we're going to do is we'll figure out a way to send in a link through the Q&A section, or maybe we'll send the class groups, and you guys can enter. We'll upload the PDFs and the recordings of the webinars on our websites as well. But if you guys wanted to like the links to be sent to your email, we open up a Google Sheet link where you can enter your own email address, and we'll send the webinar link over there once we upload it. So just give me a second. Shika, can you go back to the slide with the future workshops? I can introduce them as well. Okay,
Uh,
so just to give you a preview of the upcoming workshops, so June 1st is a 3D modeling workshop with Blender. So what Blender is an open source software for 3D modeling, and that's actually what many game developers use to design the assets for their games as well. So do be sure to check that out. The trainers in the Blender workshop have a combined experience of around 4 or 5 years working with Blender. So obviously they're very experienced, and you'll be able to see how exactly asset design and scene design is done for games as well. So the next workshop, which is tomorrow, would be done on the same webinar link and at the same time. So it should be 4 to 6, although they may run ahead of schedule as well. The second workshop after this is the Python automation workshop, which is more of a coding workshop, but it's on an advanced level. So what Python automation workshop would do, they're going to use either the Django or the Flask IDE or the framework, and they're going to show you how to code with Python over there. So that's something interesting if you want to check out with that. And the same thing, the June 3rd web development webinar, it's more of web app development with Python rather than regular coding. So it's more of a niche field. So you can check that out as well. And June 4th, which is the final webinar and the most beginner level webinar, is the app development webinar with MIT App Inventor. So you can check that out as well. All of them will be on the same webinar link and at the same time. So make sure that you guys check them out and don't be late. We are getting a question about whether we'll have another game development workshop. So as of now, in this week, we won't be having one, but you will be glad to know that we're planning on organizing a hackathon sometime in the future. The exact details haven't been revealed yet to the public, so I can't really say more, but we will be having an actual hackathon uh, with game development as possibly as a category in it. So you guys do keep a lookout for that on my GIIS and on the GIIS Tech Club social media. And remember to sign up for it when it does come up. There's going to be other categories other than game development as well. And if you register for that, we'll have a training workshop specifically for hackathon. So you can look into that as well. All right. So we're having the hackathon in July end. It's most probably going to be a virtual hackathon given the current situation, but we're not really sure. So I won't say anything right now. It's going to be in the middle of the Steam week. And it's going to be a virtual hackathon, most probably according to our teacher in chat as well. So please do keep a lookout for that. We'll probably be sharing more information with you sometime in the future. So keep checking my GIS and the GIS Tech Club social media as well. Other than that, we talked to our teacher in charge, and we're planning on releasing the recordings and the PDFs for this uh, on our website after it goes live, which it should go in the next week or two. So do keep a lookout on GIIS Tech Club social media for that. And the registration for the hackathon would take place in the first week of July. So that's when you should be getting the emails and the e-consent for the same. So make sure you register for that as well. Other than that, if you guys have any other questions, you can put them in the Q&A section. I do have a question regarding the Flask MySQL webinar. So the problem is that webinar has a separate trainer. Who knows what exactly is going to be taught in that webinar. If you guys do have any questions, you can reach out to us on Instagram DMs or our email ID. Which is also available on Instagram. If you guys have questions regarding the webinars, although I cannot answer questions regarding future webinars as of now, so I apologize for that. If you guys have any other questions, you can put them in the Q&A right now, and we'll take final questions before we end up winding up. Okay, so we're getting questions regarding whether we've ended the webinar. The thing is, we ran a bit ahead of schedule and we covered most of the part on time. We were expecting a lot more questions and like technical difficulties, so which is why the timings for the webinar were 4 to 6. But we have finished it, and we're taking this a bit of time for Q&A before we wind up. And before I forget, I'd like to take this chance on behalf of the GIIS Tech Club to thank the IT department of the school, especially Ravneet ma'am and Sugna ma'am, for their constant support in organizing these webinars. And I'd also like to thank you participants for attending this webinar and keeping us interactive as well. Okay. At what website will you send the recording or the webinar of the PPT? We're still looking into that with the teachers. We're either going to share a drive link with you guys somehow, or we'll upload them on the GIIS Tech Club website. We will inform you of the same either through an email or through the class group, so keep a lookout for that. And are we going to do all of them? Yes. So the thing is, you guys are free to attend all the future webinars. So you're not really restricted to one webinar. That's why they were kept on separate dates. And it's the same webinar link on the same time. So 4 to 6 every day for the next week till Friday. So you can, so make sure you attend those webinars as well. So for now, I believe those are all the questions answered. And unless Srikar has anything else to add, that would be the end of the game development webinar. We thank all of you for attending, and make sure to check out the future webinars and GIIS Tech Club on our social media and website as well. Thank you. Ramneet ma'am, you have to end the meeting.
Yeah, okay. Ayushmaan, if they all need these recordings and any references of documents, we can create the Tech Club Drive, and then we can just give the drive link for view option to all of them.
Oh, yes, ma'am, we can do that as well. So
Once
I'll have
all these
Ayush and Srikar.
all workshops are over, after that we'll put it together.
All right, ma'am. So you guys all heard, ma'am. So we'll make a drive link with the PPTs and the recordings of each webinar, and then we'll share it with you guys somehow.